Learning about the marine ecosystem is one of my many passions. When I moved from the UK to Australia in 2000, I instantly fell in love with the ocean and all of its biological organisms. One of the most abundant and significant molecules in the ocean is calcium carbonate. The diversity of this odourless white powder is astounding. It exists in many forms, from eggshells, chalk, limestone, can be used for medicinal purposes, and for me, more interestingly, it is the skeleton of coral, or commonly referred to as the rainforest of the ocean.
The structure of calcium carbonate is built with a carbon atom that is covalently bonded to 3 oxygen atoms. One of the carbon to oxygen bonds is double bonding, reaching the octet rule. 2 oxygen bonds have a single bond with carbon, however they are ionically bonded with calcium. Oxygen is a negatively charged anion, therefore calcium is a positively charged cation. Calcium carbonate is produced and excreted at the base of the coral. The production of this molecule is primarily for protection. It forms into a hard shell that can vary from different species, creating magnificent shapes. This is called the coral skeleton. The living organism being sheltered inside is called a polyp, and it's also home for thousands of other marine animals. This molecule can shape into crystal lattices that are repeating building blocks for the polyatomic ions. Polyatomic ions suggest that the ion has 2 or more atoms. This ionic crystal lattice with strong electrostatic forces provides a solid structure which is necessary in the role of the coral skeleton. It is evident that calcium carbonate is immiscible and remains a solid structure in the ocean when the pH is at 8.2. Although, as research shows, the ocean's pH is lowering. This is due to the high anthropogenic CO2 emission from the atmosphere diffusing into the ocean, which leads to carbonic acid. Research identifies that carbonic acid, like all acids, will release hydrogen ions. These hydrogen ions will have a stronger ionic attraction to carbonate than calcium in calcium carbonate molecule. Therefore, hydrogen ions will take the place of the calcium ions that these hydrogen cations and carbonate produces bicarbonate. These equations refer to the solubility and ion concentration of calcium carbonate. This is an experiment I conducted that shows the reaction of calcium carbonate when attacked by an acid. Therefore, specifically identifies that unless in an acidic solvent, calcium carbonate will stay as a crystal structure if in a basic solvent.